Hello, this is Advent of Code 2024. I'm Noah Mann. I'm the author of FunctionalJ.io, a Java library that brings functional goodies to Java, allow us to write more functional style code in Java. We'll discuss day 5 in this video. All the code and all the link will be in the video description. Day 5 puzzle is related to the FAQ of our profession, and that is, can you fix my printer? That's right. Elves are trying to print out the Slayer launch safety manual, which has been updated. But the printer has a peculiar rule, and that is the page printed have to be in a particular order. In this example, these are a setup order. So page 47 need to be printed before 53. It doesn't say that have to be printed immediately before. Just that 47 have to be printed sometime before 53. And these are the list of pages that need to be printed because they're the update of the previous manual. The first update involves printing 75, 47, 61, 53, and 29. But then we see that there is a rule govern that 47 need to come before 53. And in this case, it is correct. There are other rules like 97. Let me delete this. Like 97 need to come before 13, but 97 and 13 are not related to this update, so we ignore it. We will have to go through all these rules and see if the page ordering rules are obeyed for this update. What they want us to do is to sum up all the number that is the middle of each update. So sum them all and get 147. That's the puzzle. So the solution will evolve around going through all the updates and then see if any of these updates are valid based on the rules. And if they are, we just pick the middle one. If they aren't, we just ignore that. To see whether or not the update is valid, we can intersect each rule against an update and see whether or not both of them in the right location. So let's say 75, 47, 61, 53, we can intersect with 47. And what we get 47 and 53, and what we get will be 47 and 53. And that will be equal. If the intersect does not have two of the rules, or if only one of them in there, then the rules are not relevant to that update. So that's one way of doing it. There's another way, and that is to pull this update and create a map. The map from this number to the index is in. So it's a map of 75 to 0, 47 to 1, 61 will be to 2. You get the point. And then for each rule, we can ask the map for the index. If both of them are there, the first one in the rule have to have the earlier index than the second one. So that's another way. The second way, it is faster because it takes 01 to get the index. So I implement both of them. Let's see in the code. So this is the code. What we want to do is to sum up the middle page. So first of all, let's see how the data look like. And that's day 5. So the data will look like this. There are number of lines that contain two numbers separated by pipe, which represent rows. And there's an empty space. And after that will be lines that represent update. So in order to process this, we need to split the files by the empty string. We can do that by the method accept until. Row lines are those lines until the empty line. Once we get row lines, we know how many of them are there. We can get the rest of the line, which is skipping from that amount of row plus 1, and we will get the update lines. Then we just convert all these row lines into the strings to int. We'll convert a string, which is each line in the row line, into int func list. So we will get like 47, 53. Another line we will get a list of 97, 13. For the update will be the same. This line we will get 75, 47, 61, 53, and 29. There we have the rules and the update. Now, for each of the update, we see if the update has the correct order. So we pass on the update and the rules to these functions. If it's the correct order, we then get the middle. So see the size of the update, like how many of these pages divided by 2. In Java, an integer division will floor by default. So in this case, we have 5 elements divided by 2, we get 2.5. It will be floored to 2. But because it's 0 index, so it will be 0, 1, and 2. So it will get the middle. And we map this into an int, and then we sum them. We get sum of all the middle pages that are in correct order. Now dig into the correct order update. The first method that I mentioned is to intersect. And to intersect to functional list, to in functional list is to use the method filter in. So we go to all the rule. All the rule have to match, right? So this have to return true for all the rules. And we need to check if the rules are correct or irrelevant. And what we get is to see, to intersect first. So we filter in, update, we filter by the rule. So this will go through all the elements in the update and see whether or not they are in the rule. So that equivalent to intersection. And if the match order is not equal to 2, that means the rules are not relevant. We ignore them. So in case that it is, then we see whether or not this match order is equal to the rule. Okay, so this is the first way. So that is a faster way in case you have a lot of those, but you don't mind that it take more memory. That is to convert update into a map, but reverse the order. And this will create a map of the data from the value to the index. So see from this picture, we'll generate a map like this. From that map, we will go to all the rules, and then from the rules, we will get the first number, first page from the rule, and the second page from the rule. If they both are not null, then the first page need to be less than the second page in order for this to be in order. So all of the rules have to match. So we run that and all pass. That is it for the first part. Now let's look at part 2. Because we already get the one that has the right order, send it to the else. Now we can start working on the one that is not in the right order. So in this example, we have this, in which we need to fix it into the right order. The ask is that once it's in the right order, we want the same like before, and that is to sum the number of the middle pages after it's already been in the correct order. So the first order of business is to put it in the right order. And then I come up with 2 different ways. The first one, it will be slower, but it's likely to be correct. And the later one is with some other assumption. So let's take a look at the first way first. Okay, from all these rules and updates, let's take a look at only one update. I make a mistake, pick the one that is correct, but I reorder it to be wrong. So let's see. So as you can see, we have a smaller set of rules. These rules are only the one relevant to this update. So we only focus on this update. And these are the relevant rules. If we collect all the pages that should be earlier, so all in this column, into a list, call it earlier, and then the list, and then the one that should be later into the later pages, this here, we will find that if we subtract the earlier with the later, we will have the pages that will never be after anything, right? So this one, actually there are many of the 75, but reduce it to a unique, so we get 75 to be the first page. And if we do in the switch order, so we subtract the later with the earlier, we will get the page that never become an earlier page, which means it's going to be the last page. So we know the last page. Since we know the last page, we can get the middle pages by subtract the first and the last out of the update. So in this case, from this from this update here, now we get this one left because we remove 75 and 29. We can repeat the process. Again, these are relevant rule and these are the new update. So this is a new update, which is the same with this guy. And these are the relevant rules. Then we can calculate the earliest, the latest, first, and the last. At the end, we can find the middle pages, which if we only have one middle pages, is the middle page that we want for that update. So this is the first method to do that. So now let's see the code for the first solution. We first get the relevant rule. Okay, let's go up a little bit. Here, to find the sum of the middle pages, again, we do the same, get the row lines, except until empty line, and the update, so on and so forth. But then we filter first, only for the update that has the incorrect order. Then we map that into relevant rules. So in this case, we pass on the rules and update. We get the rules that are relevant. Then we find the middle pages. We only need the rule. We don't need the update. The update we already use the update to figure out the relevant rule. Okay, so the incorrect update is similar to before. I used the intersect, which is the one that I do it earlier before I used hash map. But this is modified to pick up the incorrect update, and that is incorrect update. And that is one that is not equal. And then for relevant rule, I just filter the rule that they both are in the match order. So we get the relevant rule. To find the middle pages, we first create the earlier pages list, which is only the first part of the rule, right? Because the earlier. And then the later pages, which is the second part of the rule. Then we exclude all the later pages from the earlier pages. So like subtract here. Then the only thing left should be the first page. And then we do the same, but switch order. We get the last page. Then we subtract the first page and the last page. We get the middle pages. If the middle pages has only one side, then we just return it. Otherwise, we reduce the rule. So the rules that has the first or has the last, that should be removed. And then we recursively call the find middle pages. Okay, so that's it for the first method. So now let's see the second method. The second method, we take a look at the rules here. These are relevant rules. Then we create a histogram of each page, that how many times it was the first page. Sorry, how many times it was the earlier page. So this is this earlier to see. So in this case, we get 47 become earlier page 3 times. So 1, 2, so 1, 2, 3. So 3 times for 47 and 4 times for 75. So that is for 75. I think you already can guess how to find the middle page. So if we order this page, once we ordered it, the one in the middle is the middle pages. It makes sense because the first pages will be the one with the most number of time that it become an earlier, and so on and so forth. So the middle page will be the middle one. So from this understanding and from this algorithm, let's see the code. So I put that new code into quick find middle. And in this one, we first take a look at the rules and only get the earlier page. Then we find the frequency map. So group by itself and the size of the list. So when you do a group by, you get the key here and the list of all the value, like of all the value in there. And the value itself is the itself, content of itself, but there will be more of it. So we can map it to the size of that. Once we get the frequency map, we can sort it by the value, which is the frequency, and then map it into the key, which is the value of the earlier page, right? After that, we pipe. So this pipe is the same with the functional piping. So use the pipe character. That means this result in a map, right? So we first, func list. From this map, we only get the entry, which is func list of entry. Then we sort by, the sort by keep the type, right? And then we map it into int. So what we get at this point is the integer func list. And then we pipe it. Therefore, this integer func list will become the key here. So we get the key and then find the middle of that key. The result is the key that's in the middle of the page. If you run it, you get the green as well. It's much faster than another, the earlier method. That it is for part 2. I would like to highlight the fact, as you can see, that we can write this code pretty much in the functional way. There is no procedural, no object oriented here at all. So this is the power of functional J. You can write Java in this form. It is debatable whether or not this make it easier to understand if you are not familiar with functional programming, as well as it's debatable if these are the fastest way of doing things, and they have to be balanced. Functional programming in the right type of problem, and I think this one is, it is quite readable. It's very readable indeed when you do it in functional form like this. And the performance is very similar to using Java Stream, because all of these use Java Stream in the backend. It is a trade-off that we have to make between readability and understandability of the code and the performance. All right, that's it for day 5. The code and all the link related to this will be in the description. If you learned something, please click like. If you want to know more, please subscribe. For today, thank you for watching. Bye-bye.